The Solar Podcast is brought to you by Continental Energy Solutions. I'm Tim Montague, your host. Today on the Solar Podcast, lifecycle performance management of solar assets. My guest today is a repeat guest, Dan Leary, CEO of Denowatts Solar. Welcome back to the show.
Thanks, Tim. Great to be back.
It's wonderful to see how your company's evolving. You've rebranded a little bit, same name, new identity. And but we are going to, after you and I spoke about a year ago, one of the burning issues for me to fully appreciate what Denowatts does is to talk about some practical applications of your technology. And so you and I are going to do some back and forth today, talking about various aspects of how customers can leverage your technology. Give us just a brief background on your experience in the industry and how you came to create and run Denowatts.
Absolutely, Tim. I've been in the solar industry since about 2006, starting off as an installer in the early days, and built a development company and put together some other types of companies to solve problems that I know we're all facing. So for us, it's, I guess I've made a career out of asking why and saying, how can we do something better? So that's what has led me to Denowatts. At it about 6 or 7 years now, and starting to see some great results.
Excellent. So when you think about solar assets, let's set the table a little bit for our developer and finance and asset owning colleagues in the industry. What are their primary concerns when it comes to solar farm performance?
Oh, sure. So it starts off with getting the transactions together, getting the project developed properly, and then making sure that the whole process of getting it put into service happens efficiently and it's performing as it's supposed to be. And then so I kind of call that like the early stages of the total life cycle. And then once it goes into service, you've got decades worth of performance management. And it's all about, I think everybody's concern is how do we scale this industry and make it so that, the team that's overseeing 100 systems right now can oversee thousands in the coming future, because that's where the industry is going. So it's all about efficiency and speed and being accurate in how we do performance management.
I put a long list that you've created that captures this on screen, and the viewers probably can't read all this. So I'm gonna go through the list, and then we're gonna do some Q&A on each of these. But you've got the energy model at the outset, your benchmarking system, which I'm not sure what that is, but we'll get into that. Commissioning is, you're energizing the facility and making sure that it's in compliance with the grid operator, the AHJ, et cetera. Capacity testing is the basic facility as constructed, performing as designed. Learned power, energy accounting, energy reporting, operations and maintenance, and business intelligence. And that is a very long list. Are you suggesting that Denowatts can help customers with every aspect of this list?
Oh, absolutely. The life cycle of a solar project, it literally goes from developing that project and putting it into an energy model and coming up with your financial pro forma, and it goes for decades of management. So getting all that done correctly is our focus, especially as it comes to the data management and learning from our data.
Yeah. So let's just dive into some of these things. The energy model. Why do we need an energy model?
Sure. Well, the energy model is what's going to give us our predicted pro forma. They'll be used for the financial pro forma. So as a developer and a independent power producer, or the entity that's going to own the project is evaluating an asset or the potential for an asset to join their portfolio, they have to look at, well, what is this asset going to generate in terms of power and certainly other revenues that come from it. And so the very first step that a developer would do is develop the energy model, which is looking at a few things. One is like the resources. So given your part of the country and your the technology you're going to use, what are the resources, how much sunlight you're going to have to produce power. The second part of the model is really the electrical model, which is given the resources, how are you going to be able to convert those photons into electrons, and what's the efficiency of that? So at the end of the day, it'll tell you in a given typical year how much power, hence how much revenue you're going to be able to generate from that asset.
Yep. Power and revenue. Those are two vitals. And what you reference over under modeling. What is that?
Yeah. So what I've put together here is a list of lessons learned through these different life cycle parts of the life cycle. That there's multiple lessons learned for each one of them. So I'm just going to touch on one of them. And the one that sort of came to mind because it's such an easy one for us to look at is, did we get our energy model right in the first place? Specifically looking at the power model. And what you see on that screen there is we call it a feedback loop. It's looking at all the energy models that come into the sites using Denowatts, understanding how they're derating and how they're going to be setting up the electrical throughput, and then helping to identify what's the correct model. It's possible to be too aggressive with a model and take very aggressive engineering assumptions. And likewise, it's possible to be too conservative. And you don't want to be either. If you're too aggressive, you have a chance of not being able to pass your capacity testing and live up to the expectations that you've set. If you're too conservative, well, you're leaving money on the table. Somebody's leaving money on the table. So being able to hit your output and hit it on the nail on the head is important.
Let's talk about a few other aspects of this modeling, though. You say that you need a feedback loop using community-based data and real testing results.
Right.
But if we're just at the modeling stage, I'm not sure. Like, it feels to me like you're talking about some post-construction thing. If this feedback loop, how does that work?
Oh, sure. Well, as the industry is setting up its contracts there's going to be a buyer and a seller of a solar project. We have to know what we're paying for, and we have to know what we're selling. So generally, the energy model is something that's agreed upon in advance, and coming to what's the correct model is something that both parties should be doing, and to help guide them to what's an accurate model to arrive at is what we're calling the feedback loop. This is one of the services that we offer, where in a simple screen on our platform, you can look at how your model compares to other models that have come through and see if you're too conservative or too aggressive. And namely, it's looking at it from the standpoint of, when I talk about the feedback loop, well, we do capacity testing also. So reporting back in on the capacity test, well, let's understand what's hitting its mark on the capacity test to help us understand if our models are getting put together correctly.
Yeah. And then you also, you say that independent engineers can reference a history of projects with similar technologies when creating and validating models, that suggests that you've got some database that you're tapping into. Is that the database of Denowatts customers or some other database?
Yeah, this is the folks using Denowatts, looking at and everybody's model is being redacted, but understanding what is going on with the broader community. We call it looking left and looking right, to understand, well, given bifacial technology or given tracker technology or given some other types of module technology, what is most appropriate to use for modeling, and are those hitting their marks? This is certainly a point of this is a learning point for so many people, because the industry is growing fast. New technologies are coming out quickly, and everybody's really sort of thirsty to understand what the data is telling us. So that's why we put this here. And independent engineers, it's a while they are certainly the subject matter experts in this, having this type of resource to reference is very, very helpful.
Agreed. So let's talk about benchmarking system. And the problem you state is that weather station variation and common errors lead to higher measurement uncertainty. And what, frankly, when I hearken back to our original conversation, I think of Denowatts as playing squarely in this space of disrupting the weather station. But what is the Denowatts solution to this problem?
Yeah, the weather station is something that's been used in a lot of industries and for a lot of decades. And when we got into this, we said, okay, well, like, again, you have to start asking why. Why do we do certain things? Why do we need pyranometers facing this way and temperature sensors and anemometers? And why do we need all this stuff? And when you get down to it, we come up with a conclusion that really there's two things you need to know to run your electrical model and benchmark. Benchmark means to measure. And that's the effect of irradiance that's being absorbed by the module and the temperature of the silicon of the cell. That's the entire input for resource. So we said, okay, well, what's the best way to do that? Airports have weather stations, crop systems, NASA uses weather stations. So we're solar people, right? We run power plants. What do we really need? And what this all led us to is that really it's a different type of thing that replaces a weather station. We call it our digital twin benchmarking system. And the reason is it's more than just sensors. It's actually running your energy model on board this unit every 5 seconds. And the result of that, without getting into a whole lot of detail here, is less uncertainty or more accuracy, better accuracy. And in doing so, that accuracy and reliability and speed that we can offer with our digital twin benchmarking system is helping asset managers and operators make better decisions faster.
And why do you use this expression digital twin? What exactly is that?
Yeah, it's possibly a fancy word for simulation. A digital twin is taking in this case, your solar array. You have photons coming into the solar array, goes through a series of processes, electrical processes, and you have electrons coming out the back end, going into the grid. And a digital twin is a way of simulating that. And in our case, we simulate it real time and at the site. And it's a way to do it. It's digital because it's not actually generating electricity, but it's very accurately simulating what should be happening in real time.
Okay, I get that. And then your facility is built, you go to commissioning of the system, and there's a whole variety of potential problems, but you referenced tracker misconfigured, leading to shoulder shading. what is Denowatts going to afford a customer when it comes to commissioning?
The speed and the accuracy and the real-time nature of digital twin benchmarking allows us to, as the system's it's go through startup and it's being brought online, to see what's happening. It's not common that the second you flip the switch that it's ready to pass your capacity test. Usually certain things have to get adjusted. Wires have to get reconnected together. There's tons and tons of things that EPCs and commissioning agents go through to get a project so that it's fully in service. So I just use one example here. It's one that we actually see often with trackers, and it's just tracker settings. So part of what the Dino system is doing is it's identifying is the power coming out of the array equal to the power that it's supposed to be generating, and if it's not, when is it? When is it not? And trackers are a great example because they're moving. They're programmed to move certain ways. And if they're not programmed to move and be in the position they're supposed to, we'll see things like inter-row shading, which is this example. And we could see like when inter-row shading is showing up when it's not supposed to be, well, that's an indication that we've got to make some adjustments to the tracker settings. The installer would log in to the tracker system, make the adjustments, and then in this case, for example, the issue goes away and it starts working as it's supposed to. And commissioning is a real-time thing. You don't look back a week ago and say, well, what do we have to do then? Commissioning is something that can support the team as they're doing the startup procedures.
Yeah. And then we come to capacity testing, which is analogous. What exactly is capacity testing?
Capacity testing is checking to see that you're making the power levels that your model defined and your contracts defined. And your contract is based on what was in that original energy model. Capacity testing is something that's evolved a lot over the years. And about a decade ago, ASTM put together, it's called the E121, which today, a decade later, is still probably the most commonly used capacity test. Maybe 95% or more sites use this test. And it's a way to check over the course of days or weeks to see that the power level is it's where it's supposed to be.
Yeah. And this is like an important stage gate, right? Because pretty much the facility is going to be handed over once the facility passes capacity testing, right?
Right. It's a critical milestone because often it's tied to a payment milestone. And if for example, if a site's not producing what it's supposed to be, then we've got to get into root cause analysis and get to the bottom of why it's not. And that can happen sometimes. But capacity testing is sort of it's the heart of benchmarking. Well, historically, it's only done kind of at the beginning of the project, or maybe if the project gets sold down the road. But capacity testing is something that should be ongoing. And that's part of the benchmarking system. In fact, we felt it was so important, and the processes that we use as an industry are, they're coming on 10 years old. That's like 30 years in most industries. So we kind of started looking at this a few years ago and saying, wait a minute, we're doing a good job benchmarking solar. Why aren't we looking at capacity testing? So we started doing that and finding that it was very well received by our clients. They liked that we could look at capacity testing. We started looking at the standards, the reference standards, like I said, the ASTM standard, but also a newer standard, which is the IEC 61724 series. And we came to realize that the way capacity tests are carried out, they're a bit clunky, they're confusing. And more importantly is they're done so many different ways. So what if we could just make a simple button with our technology that could download a capacity test, and it could be done to these standards. So that's what we did. And in fact, we're just newly about to publish, and I think I'm going to say it here in your podcast for the first time. We just attained what's called ISO 17025 accreditation for testing. So we're an accredited laboratory for doing solar capacity testing. I'm not aware if there's anybody else in the world that's done that, but our approach is that since we're able to have such tight control over the data and understand our uncertainty and our accuracy and the processes and the standards, well, this is kind of a no-brainer for us. Let's make a simple report that can be downloaded by any party that's using our platform and have an instant capacity test report. So we're very excited that we've just sort of hit that milestone.
I mean, it seems to me, congratulations.
Thank you.
And it seems to me like this could be a benefit to all parties concerned. What people don't want, especially EPCs, is there to be surprises, right? You don't want to go into the process of formal capacity testing without confidence that you're going to have a positive outcome. And are you suggesting though that the parties would have a signal whether or not you're going to achieve a positive capacity test?
Oh yeah, and more. It's even more than that. The commissioning process rolls into capacity testing. So once you're through commissioning, you can look into our portal and say, okay, we're hitting the power levels that we need to be, and you can get a pretty good sense. You can get an excellent sense just by looking at a screenshot. Are we in a passing zone or not? If not, call us up and we'll try to help, get to the bottom of what could be going wrong. But when you get to the point where you're at a successful, you should be successful. We'll start a period of generally a minimum of 3 days, and usually capacity tests can be wrapped up in 3 to 5 days. And every day you can download and see the progress you're making. Generally, for a passing capacity test, you're hitting a certain performance milestone of, call it 97, 98%. You're hitting a certain number of minimum data points, good data points. So you got to have sunny days where you're getting a certain amount of sun and stable sun and several other things. So every day, and I say this because we have some great clients and EPCs that look at this every day to know, okay, when exactly we're going to hit our passing milestone. And once they hit that, they can request that a draft report become final. And this is part of our ISO accreditation is to look at all aspects of it, make sure that the measurement uncertainty is an acceptable level according to the contract, make sure that there's no outlying data points or underlying issues in there. And then they can take this report, bring it back to the counterparties or to the independent engineer who can validate if it was a passing test or not.
Very good. So what happens next? The array is commissioned and handed off, and it's just out there day in and day out. What is present? You referenced something called learned power. What is that, and what do asset owners need to be looking for in the long run here?
Learned power is something. This is our view of the beginning of sort of the life cycle, the next few decades of asset management. The energy model is a way for us to come up with the sort of the power model and the pro forma of what we expect it to do. They're developed before the site goes into service. They use things like an estimate of trees and shading and soiling and things like that. And what we, as we start to talk about other things we'll talk about next with energy accounting and outage management things, what we realized is, that energy model is not necessarily going to be the most accurate. More importantly, we have the ability to actually learn the energy model, the actual energy model that's being produced. We have the ability to use AI tools, for example, to learn what the array historically has been doing and what it should be doing to identify, what is the actual shading profile of a site. What is the sort of the systemic and the soiling losses that we've been observing? How do the trackers normally work? And so the benefit of learning the actual energy model is to more efficiently be able to come up with some of the accounting and reporting processes that we'll talk about next, as well as it's really a benchmark of itself. When we have a commission benchmark, the day that we know that this site was turned on, working perfectly, it passed the capacity test, it got a score of 1.0 or 100. Okay, well, what happens to that score over time? And that's what learned energy is telling us.
I'm curious, as the asset, as the solar array ages, right, it's going to produce less power because it's degrading. The technology is degrading. And then you have variables like shading that might occur from weeds growing up in the solar farm, or shading from dirt accumulating on the glass of the solar panels, or a lot of bad weather like snow. And so how can you explain how you tease apart these various factors and arrive at a go, no go decision? Basically, is there a problem that needs to be resolved, or is everything basically honky dory?
Oh yeah. That'll sort of go into some of the next lessons learned, which is we talk about O&M and how you effectively manage assets and things. But to answer the question here, so first is teasing apart soiling. It can be in the form of snow, which is relatively simple to identify when there's been a snow event that's resulted in underperformance and when that snow event clears itself. Same, because they're generally shorter term events. Another one is you had just mentioned vegetation. Yes. When is it time to mow? Because so once you watch your power level draw off at certain times of the day, and you scratch your head, pretty quickly you realize, okay, we should get eyes on and see if there's vegetation, because often that's the case this time of year, and you can see when that event clears itself as well. Soiling, there's a couple types of soiling. Some are short-term soiling that can be resolved after a rain event, which we can detect, as well as longer-term soiling and systemic losses. There's systemic losses are a more difficult thing to tease out. And the systemic losses are the reason why it's important that this whole process of energy accounting have a good deal of human supervision to it. It would be nice to be able to let the machines do 100% of the learning. That's not necessarily what's going to give us the best results. In fact, the interoperability and coordination with other services is really important to this. You've got your O&M providers that can help you identify certain conditions on the ground. You've got aerial scanning and infrared imaging to help us identify, well, is there a module degradation issue, or is it that certain strings are down because there's MC connectors have come apart, things like that. So getting into those details, it's very important. And I'll just say also, I forgot the obvious one is just outages. When equipment suddenly goes down or starts to derate and then it comes back up, well, those are probably the easiest ones to identify. But understanding the magnitude of those outages is what energy accounting is really all about.
Is there more to say about energy accounting?
Yes. So I guess what you put up on your screen here is the reason this is something we started on about four years ago or so. Operators just spending too much time trying to document and identify it, and not enough time trying to fix it. So, you know, the idea of combining our digital benchmarking system with the AI and leveraging machine learning and neural networks and things like that to help us figure out when there's an event, so that we can sort of hand it to the energy engineers and the O&M providers, so that they can go, rectify the issue. So it's really a way of just making the whole process more efficient for everybody, especially the O&M providers.
And in these graphs that you have, there's 3 lines here. There's black, yellow, and magenta. What is the difference between those?
Yeah, this is a way of us helping identify where did the missing photons go. I think you might have on your screen have shown some black bars that represents the energy that was produced and made its way out to the grid. Yes, we got paid for that. But then there's orange bars that represent systemic losses and things that require further investigation. Could it be advanced module degrading faster than it was supposed to? Could it be DC? Could it be DC strings coming undone? Could it be could it be soiling and things like that? So that's what the orange is. The green represents the learned shading profile of the site. And then finally, in the blue represents energy lost due to snow events. And then the gray is items that just needed to be further investigated, but we tracked them as an outage. So what you're looking at here with this energy reporting is a aggregate of a large portfolio. That's the benefit of business intelligence tools like Tableau. We'll talk about that in a little while too. But it's a way to help us understand, where's the photons going. We'll put it to metrics that people understand. The availability, for example, is a metric everybody understands, and energy performance index.
My question was about the previous slide. I'll put that on screen here.
Yeah.
Where you've got these line graphs with the black, yellow, and purple or magenta. Are those just different days, or just trying to understand this?
Sure. So as you're looking at that, so this is what our machine learning is doing. The purple line represents our learned energy profile. So given the actual conditions at the site, that is the power level based off of how it's been performing that it should be hitting. The black line represents the measured power that's coming out of the meter. So ideally, your black line should be right on top of the purple line if everything's working properly, and if we're learning the profile correctly. So where you could see in the second day is where we picked up an outage, and we determined that outage was caused in part by an inverter, a string inverter coming offline or switching out partway through the day. The yellow line just represents the irradiance. It's more of a reference point.
Okay, got it. Was there anything else about energy reporting that you wanted to say? I gather that, well, I guess that's a question. Is a customer leveraging a bigger data set than their assets, or they're leveraging their assets?
Yeah, for energy accounting, it's your portfolio. It's the type of thing that I still see so many of us are just sitting down at the end of a month and plugging all our data into Microsoft Excel and trying to come up with a report that says this was the good and this was the bad. And our energy reporting is a direct result from the level of accounting that we do on a daily basis of the assets of the portfolio. So it's an instant view of it's a time saving tool, and it's a way for, everywhere from the O&M techs all the way up to the C level of that organization to see what's going on. It's very important tool.
Okay. Let's talk more about O&M. That's a favorite topic of ours here at Continental. We have a robust O&M operation. If you are owning and operating solar farms anywhere really east of the Rockies, we would love to talk to you about performing O&M for you. And but I'm going to put your slide on screen here, and let's talk about this graph to make sure I understand what's going on there. There were some events that triggered presumably a truck roll, which you've got marked with a wrench and a screwdriver, but I don't see a lot of difference necessarily from event to event here. So explain what's going on.
Yeah. Well, this is a static image. So if you if we had the ability to mouse over and click on stuff, we'd be able to see what those little wrenches mean and what was tried. So starting on the left, the first day, most people recognize this is a profile of a system that's a single axis tracker. And the black area is the amount of energy that's been generated over the course of the day. And our algorithms picked up, and let me say that the orange line that goes up and square at the top and then comes back down. Well, that's the expected power that is supposed to be coming out of this the solar array, based again on the design. So what we pick up and what we're learning about this site is that, well, we've got some shade. We know that there's a little bit of inter-row shade that results from this tracker. But more importantly is there's a lot of red. Red is never good. Red means that there's a loss of, there's underperformance. There's a loss of power at that part of the day. So, talking with the owners of the site, we were kind of looking at it and saying, well, it's possible that our tracker settings needed to be adjusted because this was sort of a newly commissioned site. So the first wrench you see there is we went and noted that we adjusted some tracker settings. We look at it the next day. Well, that didn't change it. So we said, okay, somebody's got to get their eyes out on the site. And sure enough, it required some maintenance, vegetation. The vegetation was just growing fierce at this site. So right away, they get out there with a mower, they mow it, and then you can see at the point of that second wrench mark that, well, then the next day, the site's back online. You don't see any red. The site's performing as it should.
Very good.
And Tim, I'll just say that they look like simple charts, but what's important behind this is like the usability and the interoperability of it is for an owner to be able to coordinate and communicate with their O&M, with Continental or whoever their O&M is, so that everybody can efficiently work through the process, get to the root cause of underperformance, and manage it. And then very importantly is we have to be able to verify the results. And that's what this chart shows is a relatively efficient system with verifiable results.
I like it. So we're down to the final section here called business intelligence. And the first thing that, I'm drawn to is that scattergram. I'm going to put this on screen, but tell us about that scattergram and maybe what do you mean by business intelligence? Because it probably means a different thing to different people.
Well, business intelligence is a way to help us all make better decisions through data. This is what we do. We're data. We're leveraging all these tools that we've just talked about, communicating them, and helping people make better decisions. A lot of times, data. Everybody's heard the term whack-a-mole. The people that are really engaged in the data are playing whack-a-mole. They're dealing with alerts and alarms and things, and they don't know. We don't always stop and and look back, and I think the term is see the forest for the trees, and understand, okay, well, what's working, what isn't, and how are we going to use that information to get ahead, to make better, smarter, faster decisions that's going to, make your organization more successful, make solar better for everybody. So that's really what business intelligence is. It's a way of boiling down all this information, the data mining that we're getting from just loads and loads of data. Say, okay, well, what really is working? What's actionable? What you have on that screen and that scatter plot, this is one of a lot of different modules that we have in our system. First and foremost, to me, business intelligence, the way to do it, it's a process. It's not a magical tool, it's a process. And we have to define what it is we want out of this process. So the first question I always do, like I said in the beginning, ask a question. Like, what is a question that we want to understand? In this case, we might look and say, okay, are modules degrading at the rate that we expected? Are they degrading at 0.5% per year? That's what a lot of people will use is their standard or reference point in their pro forma. And this chart answers that. Scatter plots might ask, are we seeing the system derating over time? Is it following a consistent derate, or is there actually more of an impact from temperature and things like that? So that's kind of what we're learning here with this particular graph.
So the orange dots are the actual data. The blue line is the expected. Is that?
Yeah, exactly.
Got it.
Yeah. So what this particular chart was telling us about this one site, just looking at it a little bit closer, is that we have an installed system. It's been installed for just over a year. It's got a certain design point of just under 2.8 megawatts. And what we're observing it operating right now, it's operating just over 2.8 megawatts. So, this is an example of a site that's outperforming its expectations. And what's important about this is that when you see that and you say, wow, here's a site that's doing a couple percent better than we're expecting it to. Why? Well, was it the design? Was it the equipment selected? What's the common thread? And then when you start looking at it and say, well, let's look at other sites using this module. Are we seeing the same results? Let's look at other sites that use this type of design. Are we seeing the same results? And that's what business intelligence is figuring out what's working so you can keep doing it more. And as well as saying, where are we just not having the success we'd hoped for?
Yep. I'm going to make a couple of announcements and then we will wrap up the conversation. I think we'll put Denowatts in context for our audience with what are the alternatives. But before we do that, we are promoting the Tesla raffle for the Illinois Solar Energy Association. If you go to illinoissolar.org and click on Win a Tesla, you can buy tickets right there. We've been doing this for 8 or 9 years, and we are raffling a Tesla Model X, which is a premium all electric pure EV luxury SUV made here in America. If you're not familiar with the Tesla, just Google that, and it's a beautiful car. Tickets are $100 or 4 tickets for $300. So please go to illinoissolar.org and support the Illinois Solar Energy Association. I also want to encourage our listeners to go to cesnrg.com and subscribe to our YouTube channel right there, the red button. This is where all of our interviews live. We're bringing you week in and week out great content on wildlife and solar, on Solar App, which is speeding solar permitting for residential solar. We bring you interviews with developers like UGE Solar and thought leaders like Greg Nemeth, who wrote a wonderful book on how solar got cheap. So check us out at cesnrg.com. Give us a thumbs up and please share it with your friends and make comments and reach out to me. I love to hear from my listeners.
And if you have ideas for topics or guests on the show, we're always looking for relevant content to bring to our audience. All right. So Dan, tell us about the ecosystem that you play in. Who are your, what is the raison d'etre for Denowatts that sets you apart, I guess? You know, if developers are looking for better, faster, easier solutions to get the most out of their assets, why should they consider Denowatts, and how are you different than the competition?
Oh boy. Well, speed, accuracy, and efficiency are our mantra. Like we're out to help the industry grow into what the industry is going to grow into. We're going to help them get there faster, more efficiently, and have better accuracy in their data. And we do this for less than the cost of a traditional weather station. So we just say, what's this industry going to look like in 5 or 10 years? How are we going to be doing all these processes? And, you know, I think not many people believe we're going to be doing it the same way in 5 or 10 years as the way we've done it for the last decade. Like I said, the industry is growing so fast. So getting ahead of that curve means learning as fast as we can, having great data to back up the decisions we make. And that's what we do. It's a complementary service to monitoring. So monitoring services, are critical to all these assets. That's how owners and operators stay in touch with them in real time. But what we felt was missing was the level of testing, the accredited capacity test, a perfect example of something that, an operator developer can sign up for now and save a ton of time. It's included in our service. It's again, less than the cost of a weather station. And it's an example of what I think the future of solar needs to look like. Streamlined services to help us get these assets deployed and lead the nation's new power grid.
Very well. I'm going to put your closing slide on screen, and our listeners can check you out at denowatts.com, just like it sounds, DENOWATTS.com. And they can register there or reach out to you for a free demonstration. How else can our listeners reach you, Dan?
Well, they certainly they call us anytime. That's my phone number right there. I'll pick up and happy to talk. And come to our website, sign up for a demonstration. We'll send you out a kit if you've never used Denowatts before, and we'll show you how it works. No commitment required. So, Tim, if I could just say thank you for the service you and your podcast are doing for the industry, especially over the last year and a half, where people don't get together as much. Since it's we don't have the trade shows and the things like we used to learn about innovation and things like us. What we're doing at Denowatts. Thank you for all that you're doing to help our industry grow and get smarter every day.
Well, thanks, Dan. I really appreciate that. And yeah, it is strange days. It's really a bummer that we're not going to get to go to SPI this year, given the situation in New Orleans and Delta variant, et cetera, et cetera. So I'm so looking forward to getting back to the face-to-face world of doing business in the industry. And our listeners should know that I totally rely on my guests to bring me additional guests and content. So please do reach out to me if you have ideas for other entrepreneurs that are worthy of a greater audience. This is a fast evolving industry. And even though solar technology is relatively mature, there is just a ton of innovation yet to be made. And that's why I'm so excited to bring you back on the show, Dan. It's companies like you that are really pushing the envelope, leveraging things like machine learning for better operations and maintenance. We want the industry to be more successful, more affordable,
more accessible, and so that we can, go faster, harder after the energy transition, and, hopefully stop climate chaos. So this is important work. So thank you. And with that, let's grow solar and storage. I'm Tim Montague. Have a great day.